All right, so welcome again to our open house. We're mostly going to be talking about fall 2023, which is what we're currently reviewing applications for. You may also at this time submit an application for spring 2024, but we are not going to be looking at those for a while yet. My name is Jeremy Matthews. I help with the application and administrative side of this program. So if you have questions about application documents or the application process, I'm happy to help with those. I'm also joined by our graduate program director, Dr. Samara, who's going to be talking about the courses in the program, the placement of the industry, and our place geographically in the U.S. So without further ado, Mohammed, take it away.
Thanks, Jeremy. Welcome, everyone. I'm Mohammed Samara. I'm delighted that you decided to join us. And so let's get into it. It's important to understand that software is not just a page in your browser or a window on the screen. Software is now the new currency. And so you have chosen to enter or explore potentially one of the hottest fields of our times. And so there's a huge demand worldwide. And what we're looking for, our mission is to seek and attract students from all corners of the globe to this really great opportunity to join us on this mission to create software that will serve humanity. If you look at, say, the products that are generated or exported or produced by countries throughout the world, it may be coal, it may be oil, it may be electronics, it may be cars, it may be something else. Software is so special because it can be produced by any country. The barriers to the production of software is low if you compare it to, say, the production of oil or gold or some other physical product. So that is the joy and the secret of software. It is certainly our new currency. So looking at the job outlook for graduates, we already said software is everywhere. So name any industry, any domain, from healthcare to finance to fitness to anything. This thing we call data, right? And certainly data science is in demand, but data by itself doesn't do anything. Just numbers and values and files on the cloud or your hard drive. It needs software. Software eats data for lunch or in breakfast and produces results, right? And so, in other words, software engineering professionals are highly sought after. And there are many positions. We'll talk about specifics in a moment here. But if you look at the state of Maryland, this is from the U.S. Bureau of Labor Statistics. You can see the number of open positions here, almost 30,000 in a period of 12 months. What's even more exciting is the projection of the growth for the next 10 years by as much as 22%. That is not a projected growth of any other discipline. So taking it all together and you look at the median pay for a software engineering job, that is already above $100,000 per year. And so looking at the US and where the software engineering jobs or software engineers are as a percentage of the workforce, you'll be surprised to know that the tri-state area, where UMBC is, where University of Maryland, Baltimore County is, has the highest concentration of software engineers in the nation, more than California, more than the Bay Area, more than Washington State, more than Boston, more than Melbourne, Florida. So you can see DC has the highest, followed by Virginia, followed by Maryland. In other words, we have the lineage and the heritage. In fact, the first international conference on software engineering took place in DC in 1975. So software engineering has deep roots here in the tri-state. We look internationally in terms of job outlook. In about a year time, we're expecting the number of developers to reach about 30 million, right? And so you can see here, there's a large growth of software engineers and developers in Latin America. We can see that India, perhaps in a year time, may overtake the US in terms of the number of developers population. The Asia Pacific is also showing strong growth. And the gray areas here, they're not discounted, but there's some growth there, and we expect that to even accelerate. Asia, rest of Asia, the Middle East, and Africa. So, in other words, if we look up beyond, a year or 2 year or 5 year span here, if we look 7 years into the future, we're going to go from 30 million in a year time to about 45 million developers. So there's a lot of demand for software developers. Now notice that we use the term software developers and software engineers as if they are the same. There are certainly similarities between them, but software engineers have distinct qualities that we'll talk about in a moment. So I want to talk to you a little bit about job outlook by programming language, because we want to understand that software engineering is not programming. And so you can see the popularity of JavaScript, right? Because it runs in the browser. You can see perhaps the Python language is becoming very popular. As a software engineer, you'll learn when to use one particular language versus another. When do you combine multiple languages together? In fact, most systems, most applications in the world are written with multiple programming languages, not a single language alone. So that's something we teach you here in this program. A little bit about me. I'm a computer scientist and software engineer by both training and education. I practice as a software engineer and as a computer scientist, software architect, and as an engineering executive, and held positions in teaching, administration, and also in the industry doing applied research. I'm very proud of some of my previous accomplishments at Harris Corporation in Melbourne, Florida, and Amulet Corporation in Seattle, Washington State. I'm also very proud of being a founding member of Florida Polytechnic University College of Engineering and College of Innovation and Technology. But I can tell you I'm more proud of the fact that I'm here looking after the software engineering program at UMBC and trying to make it into one of the top programs in the region and in the nation. So I'll be working alongside with you to teach and conduct applied research and bring innovations into this space. So let's ask this question, okay, software engineering or software is the new currency. Why now? Why should we go into software engineering now? To really answer that question, we have to go back about 6 decades, back into the 60s, during the space program, right? And so during the Apollo 11 mission, so this is a picture of 2 scientists working on that mission. The young lady is Margaret Hamilton. This picture was taken at MIT. Margaret Hamilton was charged with some of the programming aspect of the landing module, or the vehicle that will eventually reach the surface of the moon. During that time, and you can say this was a dark time, programming or software was not deemed as something men would do. And it was really kind of pushed off to women. Also, during those times, software and programming was not seen as a big component of the mission, or even a serious component of the mission. Now, Margaret saw this differently and realized that the software is a critical component of it. And in fact, she is credited with coining the term software engineering. So we're grateful and thankful for her. She worked hard and actually had to fight for that term. When she started sharing that term with her colleagues, people laughed. Software engineering? How could that be? By the end of that decade, around the 1968, 1969, it became apparent to everyone on that mission, the mission to land a person on the moon, that software is a critical part of the mission. And without it, the mission would have not been possible. In fact, it's an irony. What Margaret Hamilton did was augment the landing module with safety critical checks and conditions that was written in the software. She actually had to fight management to put that in. The management at that time, the NASA management at that time, thought astronauts are highly trained individuals, highly capable, both emotionally, psychologically, and physically and intellectually. They can't make these, what seems like a silly mistake, to put the vehicle in launch sequence while it's landing. That's not possible. That's something that Margaret ran into while she was testing the simulator. Luckily, she convinced everyone to do that, because literally as the vehicle is approaching the surface of the moon, this exact thing happened. One of the astronauts, by accident, put the vehicle in launch sequence. And at that point, the onboard computer was overwhelmed. But thankfully, and thanks to the improvements of software that Margaret Hamilton put in, that command was ignored. And the US landed first on the moon. So just imagine what software engineering has done to our future here. So now let's fast forward to today. You look at this device, right? It's a beautiful device. It's a safety device for children. Parents can look after, monitor the safety of their child with this device. It has a lot of sensors. It has multiple radios. It has a GPS. It has a camera. It has the ability to transmit voice and video, and so on and so forth. And it doesn't cost a whole lot either. What makes this device special? To answer that question, you have to say one word: software. If you look throughout this device, software is everywhere, from the user interface to the network stack to the actual chip level. If the software does not work, this device becomes not very useful. We call it a brick, and it doesn't do anything at all. So if we take a sidetrack and look at our vision of software and computing in the 80s and in the 90s, we thought people will have a computer on their desk or in their home, in their office, and they will interact with it, right? And companies like Apple gave us these beautiful designs and beautiful displays and typefaces. Others gave us what you call portable devices. Yes, that is a portable device of that era. Perhaps it weighed 30 pounds, but nevertheless, it was portable. But the vision of what we do with software is we interact with it, and then it stays there. It stays within the boundaries of this box. We were very wrong. We were completely wrong about that. And so now we go and look at where software is. Software is in the hands of millions of people, billions of people, right? There are smart devices, and this statistics here is perhaps a year old. So this number is closer to 7 billion. So if we look at the coverage, more than 80%, if not higher, of the people on this planet, on this earth, have some type of a smart device. Smart device, you call it a smart device for one reason: it has software in it. And so now all of a sudden we have billions of people touching and working and interacting with software, some with knowledge of it, some without any knowledge of it. So no longer is software just for mission critical aspirations of nations to land a person on the moon, or to do business type of accounting or word processing on your desktop computer. It's now in the hands of everyone. So now, more important than ever, it's important for us to bring diverse perspectives and diverse people into this profession we call software engineering. So I hope it was clear when we said software engineering is not programming. So if you look at this illustration here, this wheel, this part of the wheel is programming. So software engineering, yes, has programming, but software engineering is a lot more than that. It's really about the whole entire life cycle. We have to be able to plan the creation and the architecture and the building, the construction of that software. So along this cycle, we have many roles, and this is what the program give you the ability to be ready for. So there's tremendous need and shortage of professionals who can own a product. A product owner is someone who understands the big picture, the vision behind it, how it's going to be used in a business context, but they also understand the technical details, the architecture, the implementation, the components of it. A product owner understands the system level and all the details. Speaking of the system level, in order for us to create software, we need to be able to analyze it at different layers, at the system layer, the business layer, the database layer, the physical layer, and so on and so forth. Similarly, in terms of design, we need to create the proper architecture, the architecture that is suited for the application itself. We need to be able to create high-level designs and low-level designs. We need to create a compelling experience. So we need to understand how the user is going to interact with it. That's why oftentimes we say that software engineering is understanding. We understand the user, we understand the business context, we have the highest chance of creating a compelling solution. And yes, it comes to implementation. We have to write code and bring it all together, whether it's front-end code or back-end code, whether it's code that runs on the interface or the server, or code that runs the whole entire stack from top to bottom. This also gives rise to engineers who are able not only just to write code, but they're able to manage the deployment of the software. We call them DevOps engineers. And more importantly, this gives you the ability to be ready to be a technical leader. One team, one group, or multiple teams, or a whole entire organization. Now, once the software is created, our work is not done. In fact, testing and quality assurance is a core part of this construction, is a core part of all the phases. But even then, we still have to do additional testing and additional assurances to say that the software now means a lot to our users. It's managing our lives. It's controlling our lives. If the software malfunctions, in most cases, we can't conduct our affairs, right? And beyond that, we're not done. Version 1, I challenge you to find any application or any software that's worthy of anything that sat at version 1, right? The software needs to be maintained. It needs to be adapted and adopted. And maintenance does not mean fixing problems or defects. It's interesting, today we actually, the module that we're teaching in the advanced software engineering course is about software maintenance. And the amount of software maintenance dedicated to fixing problems is only 20%. 20% of all software maintenance is fixing defects. In other words, 80% is not fixing defects, but introducing new features, adapting the software, making it ready for new environments or new situations. At the heart of all this is managing both the product and the project. And there's a difference between managing and leading. And perhaps we'll talk about that in a little bit as well. So on to the program. Hopefully that gave you an insight of why software engineering now is more critical than ever. So here we're going to focus on the Master of Professional Studies in Software Engineering. So you'll have the opportunity and the chance to take 10 courses, 30 credits. Before we dive into the actual courses, it's important to clarify and demystify the difference between software engineering and, say, computer science. And also the difference in the MPS degree and a traditional MS degree. So as you saw in the earlier slide here, it's the same length as a traditional MS degree, 30 credits. The difference is really in one area, the focus. With software engineering, the focus is on the application, is on the practice, is on the applied part of computer science. You can say that information systems perhaps is in the middle. There is theory in software engineering, but our emphasis, our focus is on the application, the practice, the profession. Looking at it in another way, you can see there's overlap again between software engineering and computer science. Perhaps computer science is akin to physics or biology, where software engineering is akin to clinical aspect of medicine. So taking it a step further, what we do with software engineering is we want to create a system, or perhaps a system of systems, and we have to look at the implications of that system, not just in terms of cost, but also its ethical implication, legal implication, the compatibility implications, how reliable it is, how safe it is, how is it going to evolve over time, what context does it live in today, and what context will it live in the future. We have software that's been running for many years. In some estimate, there's software in the world that's been running for 80 years. So we have to engineer systems and software that will outlast us. That is really the real difference between software engineering and, say, programming or computer science. You're not writing a program that would be, that would live for 6 months or 2 years. You're writing something that would outlast you potentially and live for many generations. And it takes a team of people to create it. And so if we are doing programming or computer science, we may create one algorithm, one module, one library, a small frame. In software engineering, we want to create the entire building, the entire structure, and we're not satisfied with that. That structure must live peacefully, beautifully, gracefully, and harmonically in a big city with existing structures and new structures and structures that we have not even envisioned. So in this program, we draw on many resources, but we look at authoritative sources of software engineering. So for that, we go to the IEEE Computer Society. IEEE is the Institute for Electrical and Electronic Engineers. And so the software engineering body of knowledge is one resource we use in software engineering 645, advanced software engineering. And if we look at how software engineering is defined, it's actually 12 different disciplines. In other words, software engineering has 12 subfields below it. And within that, it's built on top of 3 foundations. The foundations hopefully are obvious: computing foundation, mathematical foundation, and engineering foundation. But if you look at the areas here, software requirements engineering, software testing engineering, software configuration management engineering, software engineering process, software quality, and so on. So software engineering is a lot more than just programming or knowing the C language or Python or Swift or Rust or name the next programming language. The program is mainly conducted here on the main campus And so let's dive into the core courses. So there are 6 core courses. Our mission is to change the narrative around how software is created and built and designed. We believe that software should be first and foremost ethical, and then reliable, and then beautiful. And that's the mission of this program. So everything we do in this program really is based on this mission. So we start with ethics. What are the ethical implications in software engineering? And from there, how do you engineer systems that are reliable? So for that, you need to understand how to build a structured system, how to do the analysis and design for it. And then from there, what are the tools, the techniques that you need to do so? So that's advanced software engineering. Along the way, you want to understand fundamentally how you do testing and quality assurance, and how you manage and lead a team or a project. And at the end, you would take capstone in software engineering, which would be a real world project that solves a real world problem. So those are the core courses. And then you have 4 electives. The electives can come from software engineering or can come from our sister disciplines, from computer science, information systems, human-centered computing, data sciences, engineering management. Before I go on to tying the 2 together, I'm going to show you a few of the electives here so you can see that they come from our sister disciplines, and of course some come from software engineering as well. So you can see 638, Software Process Management, that's a course that we're offering this semester. 691, Special Topics in Software Engineering, that's a course we're offering in the fall. And this course would allow us to bring emerging topics from the field, both from research and the industry, into the classroom. So, and there will be multiple offerings with different topics. So we're planning to have 2 sections, 2 different topics offered in the fall. Okay, so on to how all this ties together. We made it simple for you and identified 3 main pathways. The first one is software architect or software architecture. There is a shortage of software architects today, and in fact, there's a high demand. In a couple of surveys looking at highly paid software engineering professionals, software architect or an enterprise architect is one of the highest paid positions. So software architects are people who understand the big picture, but they're able to navigate the small details. Software architects are able to take business requirements and translate it into software requirements and technical requirements. They're able to bridge the gap between the business people and the technical people. So they play a critical and pivotal role. The second pathway is data engineering, not to be confused with data science. So data engineering is about the platforms, the ecosystem, the tools that are needed by data science to conduct the analysis. Data engineering, you can say, is more important than data science. Data engineering is to understand how data is structured or unstructured, to understand the different modalities of databases and databases genres. For example, we teach you that there are 5 different database types in the world. And in order to architect and design a new system, you probably have to blend multiple database models together. So it's not just one data model like relational. You may have to have a graph model. You may have to have what we call a key value store, all blended together to be able to have an application that scales and that will serve hundreds of thousands of users or millions or hundreds of millions of users. So it's a critical pathway The third one is software engineering management. So notice here it's engineering management. You can argue why do we need software engineering management? Let's just have engineering management. A generic engineering manager look after and guide software products. The answer is this will give you generic results. Software is a different product than physical products and requires someone who understands it at depth to be able to manage it correctly. I can tell you that in my experience, the software products or devices that had software in them that worked really well had really, really good architects and really data wranglers and data engineers and awesome software managers who understood the software, can roll up their sleeves, write code, create designs, create user interfaces, but can also fly higher and manage the whole thing. Right, and then we have two auxiliary pathways for you, consulting and training. There's a lot of demand for that, and that gives our graduates the opportunity to go on their own, launch their own consulting firm or their own training startup, or come up with a new idea altogether. Okay, we look at the pathways and the coursework and some of the electives that you would be taking. You'll notice one thing about them. I'm just going to roll them for you here. We recommend and ask that you take fundamentals of human-centered computing, because that's what we have to start with. The ethical reliability and usability of the software. The software needs to serve the user. The software should not monetize the user. The software is there to make the user better, faster, healthier, saves them time, money, make the organization better, make the world better. The software is not there to monetize their data or spy on them or distract them or have them click on things that they don't need to click on, right? Or waste their time. And so fundamentally, we need to be centered on that mission, the mission to serve us, not serve the software. We mentioned that we also have a graduate certificate, but that's not a focus of this discussion today. We are lucky and fortunate to have a faculty advisory board that includes people with deep experience in the industry and also folks who are very active in research in computer science and information systems. On to the requirements. I'm a big believer of keeping it simple, right? And less is more. So we only ask you for three things to apply to the program. A bachelor degree with a GPA of 3.0 out of 4 or higher in a related field or non-related field. So we are looking to attract student and prospective students from many fields, both traditional fields, computer science, IS, software engineering, related fields to software engineering, but also other fields, because we believe diversity is very important, very critical to the creation of software today and into the future. We apologize, the numbering on the slide is all one, but perhaps they're all just as important. So in second requirement is introductory programming course that was completed recently with a grade of B or above. Experience in the industry can be a substitute, and this would be an equivalent course to Computer Science 201 or 202. And then thirdly, math, college level math course or the equivalent. So here for us at UMBC, this would be applied calculus or something similar. So this is math 151 or 155. So pretty simple, three things. GRE scores are not required. And if English is not your native tongue, then English proficiency test results are required. and we take multiple tests, including Duolingo as well. And you can see the thresholds here for the scores that we ask for. So to apply, and we encourage you to apply here, you would send your application along with official copies of your transcripts. If you are international students, non-native English speaker, also your English proficiency score. So that's an easy one to do. The second is statement of purpose, and I'll talk about that in detail, and then your resume. We're emphasizing the practical aspects of this program. So we want to know what type of experience you have, what type of practice have you done. So you can apply at gradschool.umbc.edu/admissions/apply. So it's important to talk about the statement of purpose. And we read the statement of purpose word by word, letter by letter. So what we want you to do is explain to us why you're interested in software engineering. In other words, tell us your story. Who are you? Really, who are you? And why you want to do software engineering. Why are you passionate about software engineering? We want to attract passionate students, high caliber students who have the drive and the tenacity to change the narrative around software and software engineering. And then tell us why you're interested in UMBC as well. So really, your story should weave into the why, software engineering, and why UMBC. And tell us how you meet the requirements, especially if there's some ambiguity about how you meet the requirements from the documents that you provided. So the deadline to apply is August 1st. The full semester will start at the end of August, August 30th. And again, the URL is here for you. And it's important to end by saying that software is really different than a lot of things that we experience in the world. For the most part, software is invisible. So really, it's that invisible thing, invisible writing, invisible code that gives us the possibilities, that sort of whispers those stories and possibilities into the hardware or the physical world. And the beauty of it all is you, I, and everyone can be part of that storytelling, can be part of that journey. All that is required is the drive, the passion, and the tenacity to go after it. And with that, we conclude. We are grateful that you are here, and thank you for your time. Again, to apply, you can go to send.umbc.edu. That's a short URL that will take you to the program website. I'm including my email address here. So if you have any academic questions, happy to answer those. We're going to open it for questions and answers in a moment here. And also, if you have any administrative questions, you can send those to softwareengineering@umbc.edu. So now I'm going to hand it over to Jeremy.
So if you have any questions, feel free to just shout them out. We'll answer them as best we can.
Yes, I am a graduate of UMBC. I completed my studies in '94. I received a Bachelor's of Science in Information Systems Management and a Bachelor's of Arts in Social Studies with a focus in African American Studies. But I graduated with a GPA of 2.77. But I've been working in the IT field for almost 30 years. How can I still apply if I did not have a GPA of a 3.0?
Sure.
Great question.
Yeah, I imagine we'll each have a slight contribution here. Certainly, you're welcome to apply. We are a Master's of Professional Studies, and so we always like to see professional experience in your resume. As mentioned as well, your personal statement is a great place to talk about, the on-the-job learning and the experiences and skills that you've picked up along the way. We understand that in 30 years, a lot can change, and you might have a very different approach to education than you did at the time, and a lot more skills to bring to the table.
Okay. All right.
Thank you, Jeremy. Yeah, most certainly. Tanya, we encourage you to apply. Grading in the 90s was a lot different than grading today. I can tell you from my own experiences in late 80s, in the early 90s, securing a GPA of 3.0 in any engineering field was considered magical. So we look at every application individually. We take everything into account. Your experience and expertise and journey matters. Your presence in the classroom with other students who have less or more experience matters. We want that diversity. So we encourage you to apply.
Okay. All right. I'm looking forward to it.
Wonderful. We're looking forward to receiving it.
Yes. Another question. Will there be any introduction of artificial intelligence in any of the classes?
Most certainly. Yeah. So I mentioned the special topics course.
Mm-hmm.
You also have the opportunity to take electives from computer science and other disciplines.
Okay.
Right? And in your capstone course, you can also explore AI and machine learning as well. But we are developing several special topics courses. And so certainly that is, of course, one of the topics that would be covered.
Another question is, how many of the courses are the courses hybrid or remote?
I see. Okay. So modalities. Since this is a professional program, what we're trying to do is simulate what we do in the real world. So we have some courses that are online, completely online. We have courses that are hybrid, and we have some that emphasizes more in person. For us, the sweet spot is hybrid courses. So for example, the course I mentioned that's being taught today, Advanced Software Engineering, that's a hybrid course. So today we are doing the class in person because the students are presenting a checkpoint in their project. So they're working on a term-long project, and this is the first checkpoint. We like to see everybody in the same room. It can be easier to manage sometimes. Also, kind of the teamwork can be easier to understand and see and judge when you're in the same room. So that's a modality that is, like I said, the sweet spot for some courses is completely online. We have another course that I'm teaching. It's 638 Software Process Management. That's an online course, but we do, like I said, we do things to simulate the real world. It's an online course, but we bring students together once a month.
Okay.
As optional, we give them extra credit, but we want to bring them all in the room. And when we started doing that, students said, "Oh, wow, we love this. Let's do this more often." Right? The rest of the class is conducted through the learning management system, through video lectures, short ones, long ones, through readings, through slides, through examples, through code snippets and code examples, and so on. So there's a variety of modalities because the world has multiple modalities. The world is colorful, and we have to be the same in this program as well.
Okay. That's good to know. I think that's all of my questions.
Wonderful. Well, thank you for your time. We really appreciate it.
Right. Thank you for the presentation. It was well covered, and it gave me a lot of insight.
Thank you. Appreciate it.
You're welcome.
Thank you. And again, feel free to reach out to either or to both of us at the emails on these slides if you think of anything later.
Okay. All right. Thank you very much.
Take care. Bye-bye.
Bye-bye.